Okay, so a definition of permutation, this is in the book as well, right? And often the little side thing there. But it's an arrangement of distinguishable objects, right? So I have five different books, and we want to figure out how to arrange them, right? Can we use the fundamental counting principle? Because I have 5 things, right? So we can use, or we may use, the FCP. So what do we have? We have 5 different books, right? 5 different books. 1, 2, 3, 5. So when I go to place the first book, so I'm going to put them over here. And that's the shelf I want to put them on. How many choices do I have for my first book? I have 5 choices, right? Then how many choices do I have for the second book I'm going to place? And then, and then, and then, and that's equal to 120. So there are 120 different ways, right? Distinguishable, you can tell them apart. There's 120 different ways that I can line up those 5 books. That's larger than you thought. I would say like 25 or something. Pretty big number, right? I mean, for just 5 things, what if we took you guys, line you up? How many different ways could I line you up, right? So, because that happens a lot, this idea of multiplying, so 5 times 4 times 3 times 2 times 1, we get a special notation for that. So it's called factorial notation. And get your calculators out. You need your calculators. Factorial notation. So 5 on. Only if we're doing sinusoidal does it have to be in radian. There's no mode for your actually, you don't even have to worry about mode for your calculator ever, really. Because when you clear it, it'll be in radian mode, and that's the only mode you ever need to be in. So 5 times 4 times 3 times 2 times 1 is abbreviated as 5. Or actually 5 with an exclamation mark, which is read 5 factorial. And you have that factorial notation in your calculator. So if you go to your calculator and you go 5, and then you hit math, and it's in one of the math. Then left arrow to PRB, which is actually all the way over to the right, but it's faster if you go left once. And then you will see the exclamation mark, and you can either arrow down to it and hit enter, or you can hit the number, which is, what's the number, like 4? Okay, and then hit enter, and what do you get? You get 120, right? So that's the quick way to do this, right? Because, if you were doing this for 50, you would not want to go 50 times 49 times 48, right? Because you're probably going to make a mistake somewhere along the line. Really? You waiting for her?
No, I went first.
Oh.
I also got that, yeah.
Being quite nice, right? So, yeah. So was that guitar player any good? No? Okay. Thought I'd ask somebody.
It's okay.
Huh?
It's okay.
It's okay. Look kind of young, too.
Yeah.
All right. Factorial notation. Is a concise representation of consecutive descending natural numbers. Consecutive, right? It's got to be one after the other. Descending, going down. Descending. And natural numbers, because we think of it as an arrangement of objects, right? You can't arrange -2 objects. You can't have -2 objects, right? Objects are physical things. There has to be at least one of them if you're going to arrange them. So representation of consecutive descending natural right? The counting numbers, natural numbers. And it looks like this. So 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1. And if we generalize this, right? So say, okay, in general then, n factorial is n times n minus 1 times n minus 2 times n minus 3 times 3 times 2 times 1. Okay, unless n were 3, in which case it would be just 3 times 2 times 1, right? But if n is 100, then it's 100 times 99 times 98 times 97 times, keep going, 96, 95, 94, all the way down to times 3 times 2 times 1. Okay?
Yeah.
So that's representation, right? Yeah.
So does it always have to end in 1? Like,
Always ends in 1. Yeah. Because what we're doing is, think about, we're arranging all of those objects, right? So in the last, when we come down to that last choice, there's only one thing left that can go in there. So how many players on a baseball team that's out in the field or that's going to bat? So how many players on a baseball team or on a side baseball team? Somebody in here knows this.
what?
How many players on a team who play that day? Baseball. Major League Baseball. MLB. How many players?
20.
Seriously?
No one plays baseball
Really?
here.
It's 30. What's baseball?
Well,
Okay, there are 9 players, right? You got first base, second base, shortstop, third base, you got a pitcher, you got a catcher, and you got 3 outfielders. There are 9 players. At the beginning of a baseball game, the manager has to provide the umpire with the lineup. And the lineup is the batting order, right? The order that players are going to bat in. So how many possible batting orders are there in baseball? If there are 9 players who have to bat. So how would we express that? So it would be 9 and an exclamation mark, right? Or 9 factorial. We read the exclamation mark as factorial, as opposed to saying 9. We don't exclaim it, we simply read it. And what is 9 factorial, which you probably want to use your calculator for?
362,880.
So they could play about 1,000 years before they had to repeat a batting order, right? If you played once a day. Right? 362,880. 365 days in a year, and then there's thousands on that, right? So about 1,000 years if you played one game a day before you actually had to repeat a batting order. Okay. So really big numbers, right? Pretty big numbers. Okay, so that's 9 factorial. And you do that on your calculator, right? What's 10 factorial? That was 10 times 9 factorial, right? So all I got to do is stick a 0 on the end of 9 factorial. Now if I do 11 factorial, then, all right, then I have to work that out again, right? What is 7 factorial divided by 6 factorial? Don't work it out. Think about it first. You don't need a calculator to do this one. What's 7 factorial divided by 6 factorial? Now let's think about it, right? Okay. How do I write 7 factorial?
7.
Yeah. And how do I write 6 factorial? So what's that equal to? Just 7, right? Because these guys are going to cancel each other out, just become 1s, and you're just going to get 7. So that's one way to do it, right? I can write out 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. And then write it out 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Let's do something slightly different. What's that equal to? You could give me the calculation. Don't give me the number, but just say, how would I calculate it? What numbers would I have to multiply to get that? 6, 7, and 8, right? So here's what can happen, right? If I want to write 8 factorial, I can write 8 times 7 times 6 times, now I'm getting tired writing, so I'm going to stop here. And I'm just going to write 5 factorial. So I can choose to stop at any time. When I stop, I'll do it with an exclamation point, right? So I write 8 times 7 times 6 times 5. Okay, I'm done. Now why am I done? Because what's down here? So I can just cross those off, right? They become 1s. And we get 8 times 7 times 6, which is what? 56 times 6, 336. So when you're writing out a factorial, if you're writing out 100 factorial, you don't have to write 100 times 99 times 99. You can stop anytime you want. Anytime you get tired, or anytime you happen to see, hey, there's a 5 factorial on the bottom, why don't I stop with 5 factorial? I'll start with 5, but we'll just write factorial, right? Because I don't have to write 5 factorial. I can write 5 times 4 times 3 times 2 times 1. But I don't want to write it all out, right? So I just write 5 factorial. And that can help us in working stuff out. Like, so what's? What's 8 factorial over 2 factorial 6 factorial? What am I going to write now? I put an exclamation point, right? Because I'm done. I don't want to write anymore. I'm tired. So those cancel, right? What's 2 factorial? Just 2. So that's going to work out to 28, right? Now, of course, you can work this out on your calculator, right? I mean, there's nothing stopping you going 8 factorial divided by bracket 2 factorial 6 factorial. But you need that idea, right, with the numbers of doing this. Let's try 9 factorial over 3 factorial 5 factorial. So what am I going to write? 9. 8. Stop me when I've gone far enough. Stop, right? When I stop not with a period. It's not an English sentence, right? Math, factorial. We stop with an exclamation. We really stop. Okay? 3 factorial is 6, right? Because 3 factorial is 3 times 2 times 1. So, what do we got? 72 times 7. What's that? 56 times 9. That's easier, right? Because that's 560 minus 56. 504, right? Correct me if I'm ever wrong. Right? I mean, that happens a lot. Okay, let's try some more. Write this. Write in factorial notation. Let's start with an easy one. 6. Written as a factorial, that is 6 factorial. Right? Right? Yeah, 6! Okay, write this in factorial notation. 11 factorial? Yeah, right? We got to get rid of everything below 9. If we write 11 factorial, we're writing 11 times 9 times 8 times 7 times 6 times 5 times 4 times, but we only want 11 times 10 times 9. I got to take out the 8, 7, 6, 5, 4, 3, 2, 1, which is 8 factorial. So we write that. What about this? What's the obvious thing that goes up top? 13 factorial. What are we getting rid of? 9 factorial. And what's left on the bottom? Okay? So we got 13 times 12 times 11 times 10, that's 13 factorial, right? But it ended at 10, so we got to get rid of 9 on down. So the 9 factorial gives me basically the 13, 12, 11, 10. And we want 5 factorial, so we throw 5 factorial in there. Okay? So, you know, this could come out as a multiple choice question or something. You know, 13 times 12 times 11 times 10 is equal to, and then you see 4 different choices. And you got to choose the right one. But all of that could just be done on your calculator anyways, right? I mean, you could just plug it in and work it out, and then plug in answer A and see if you get the same. But keep in mind, I could give you an answer A that would evaluate to the same, but is not actually equivalent in factorial notation, right? I mean, you get the same number if you just want to work them out, but it's not necessarily an equivalent expression. And then to get around all of that anyways, and to force you to put the calculators away, we give you this. What's n factorial over n minus 1 factorial? Okay. And the answer is n. So how do you get that? So remember the definition of factorial, right? It's n times n minus 1, right? You take the first number, whatever it is, and you go to the next lower number, and the next lower number. You can stop whenever you get tired, which is now. So even in a general form, you can do the expansion of factorial notation, just going by definition, right? I'm going to take that number times the next smaller number, times the next smaller, times the next smaller, and so on, until I get down to 1. All right, what if we have n plus 4 factorial over n plus 2 factorial? What's that equal to? Or how do I do this? What do I start writing? So here's what we do. We start with the bigger one. Which one's bigger? N plus 4 or n plus 2? N plus 4. Okay, so I go n plus 4. What's smaller than n? What's the next smaller thing? N plus 3. Do I want to stop there? No. What's the next smaller thing? N plus 2. Am I done yet? Yeah. So, you want to stop writing out the expansion of a factorial? Just throw down a factorial symbol. Why do we stop there? Because those guys are equal. And it's n plus 4 times n plus 3. Multiple choice wise, if you don't see that, maybe you see n squared plus 7n plus 12. Right? So maybe they expanded it out. So just be aware of that. When you're doing multiple choice test and you get an answer, it's n plus 4 times n plus 3, and you don't see your answer there, then you ask yourself, okay, is the answer in a different form? Like, have they done? Oh yeah, all the answers are all multiplied out, so I would have to multiply this out, get n squared plus 7n plus 12. Okay, so you may see it in either form. This form hides the answer more than this form does, right? So it's going to force you to actually work it down a little bit closer. Let's do n minus 5 factorial. Okay, so anytime we've got a general factorial, the rule of thumb, the thing we're going to follow is which one's bigger, n minus 5 or n minus 4? Keeping in mind that n is a natural number, presumably bigger than 5. Right? Otherwise you guys are. So what's bigger, n minus 5 or n minus 4? Which ones? N minus 4, okay. What's the next lower number? 3. Then minus 3 bigger than n minus 4 or smaller than n minus 4? It's bigger. I don't want to multiply by a bigger number. I want a smaller number. So n minus 5 is smaller, right? Because what do? We take the number, we keep subtracting 1, right? 10 times 9 times 8 times 7. So n minus 4 minus 1 will be n minus 5. What's smaller? Do I want to write n minus 6? Do I want to what? I'm going to stop there, right? Why? Because we already got one of those. What do we do with them? Cross them off. When you cross them off, things don't disappear, right? They become ones. So what's the answer? Right, 1 over n minus 4. Okay? So this is just a, an example, unlike the other one where it was, the bigger number was up top and basically there was no bottom anymore, right? The denominator's gone in the previous example, and here there is a denominator, right? So it might still be around. Next, solve for n. And remember, n is a natural number. Where do the natural numbers start? 1, right? They're the counting numbers. What starts at 0? Whole numbers, right? Okay. So we want natural numbers, right? Because we're arranging things, right? So I need a thing to arrange. I can't have minus 2 in there. I can't have 0. Although, at some point we will define this. Okay, some number divided by some number minus 1 factorial, or some is equal to 12. So how are we going to solve this? Well, one thing to do is we could just work the left-hand side, right? Just try and simplify. Can we simplify the left side of this? So it's n, which is the bigger number, times n minus 1, and I'm going to stop there, right? Why? Because I have an n minus 1 on the bottom. Now what do I do? And we end up with n is 12. Want to verify that? Right, you can verify this, right? Because you go 12 factorial divided by 11 factorial, and you count your 12 factorial divided by 11 factorial. Comes out as 12. Right? Or you say, I don't need to verify that. It's kind of obvious, that one, right? Like it's 12 factorial over 11 factorial. All right, let's make it less obvious. n minus 2 factorial over n minus 3 factorial equals 10. What's bigger? n minus 2 is bigger, right? So what are we going to do with the n minus 2? We're going to do the expansion of n minus 2 factorial, right? Stopping at a point that's convenient. What's next? And stop. Why do we stop? Because that's what we got on the bottom. Cross off the n minus 3's, replacing them with 1's, gives us n minus 2 is equal to 10, so n is
8.
I do that too, trust me. Especially with this stuff. I got subtract 2. Oh, no, I don't. Wait. Hey, I do that to mess me up. So when you do that, it's a good idea to then go and check it, right? Just go and put in, because if you got 8, and it's almost a natural thing to do at times, because you just think subtract 2, and then you go 10 minus 2, instead of thinking I need to add 2 to both sides. So if you got an 8 and you went and did that, you would end up with 6 factorial over 5 factorial, and that would be 6, and then not 10, and then you go, oh, wait, something's wrong. Right? If you got 12, you'd have 10 factorial over 9 factorial, and that is 10, and go thumbs up. Got it right. Which obviously has nothing to do with Jackie Robinson, because you don't even know who he is. You don't know baseball at all of a sudden. have to be the answer to life, the universe, and everything out of the Hitchhiker's Guide. Okay, how are we going to solve this? What's bigger? N plus 2 or n? N plus 2. What are we going to do with the n plus 2? Expand it. N plus 2 times what? N plus 1. Stop now? No? Then what? Stop now? If I kept going, it would look like this, right? I mean, this wouldn't be in here. If I kept going, it would look like that. You'd see n plus, this would be in brackets. I would probably just throw that in brackets as well, right? Because you're going to hit an n, and then you're going to hit an n minus 1. So just be aware. But we're not doing that, right? We're stopping. Right? Cancel. Oh, now we're going to solve this. So how do I solve this? Quadratic, when we solve quadratics, we want to set it equal to 0. Now here's the thing. We know this has to factor. If it has a solution, we know it factors because we know that n is a natural number, so this has to factor. If you find yourself having to pull out the quadratic formula or something, just be aware that your answers have to be natural numbers, which are what? What are your natural numbers? There's a plus, there's a minus. Two numbers multiply to 40 and differ by 3. 8 and 5, which one is positive? Check. N squared minus 5n plus 8n will be plus 3n minus 40, right? Okay. Anytime you factor, you got to check. So that means that n is equal to what? Negative 8, or what do we know about n? What kind of number is n? What kind of number isn't n? So we're going to show it in our solution, right? We're going to say, look, n is negative 8, n is 5, perfectly valid, but in the context of the problem, it can't be negative, right? It's got to be a positive number. So n is equal to 5. You want to check that? Then we go all the way back up here and we say, what's 7 factorial over 5 factorial? That's 7 times 6 times 5 factorial over 5 factorial, which is 42. Right? So you're able to check that. You can't put a negative 8 in there. Go ahead in your calculator. Go negative 6 factorial, right? I mean, it's just going to go error or something similar. I don't actually know what it'll say, but it won't give you an answer. Okay, so we defined a permutation. Let's just do a little intro stuff with permutations, right? Monday we'll get more into permutations, and then we'll do permutations with repetitions, and then we'll do combinations, and then we'll do some counting problems, then we'll review, and then we'll have a test, right? Which will be, it's actually not next week. Isn't it amazing? We're actually going to go more than like 4 days without a test, so it's not till Tuesday, May the 7th. So we got a week with this stuff. But we got a quiz coming up on Wednesday next week, so this stuff will be on the quiz. So just a little introductory permutation stuff. Let's say, how can we arrange the letters? How many ways can we arrange the letters A, B, and C, or just A, B, C. How many ways can we arrange A, B, C? 6, right? You have 3 choices for the first letter. It could be an A, B, or a C. You have 2 choices for the second letter, depending on what your first letter was. Right? I mean, you can write those all out, right? We got A, B, C. We got A, C, B. We got B, A, C. We got B, C, A. We got C, A, B. And we got C, B, A, right? So those are the 6 distinguished. You could do that in a tree diagram, right? So you could go A. That could be my first letter, and then my second letter is, a B or a C, and then my third letter is a C, or in this case a B, right? So, there's some way that you can list them all if you need to. Although knowing there's 6 ways, you should be able to come up with the 6 arrangements, right? That's pretty easy. How many ways? Can we line up 4 students for a photo? Use factorial notation. How many ways can I line up 4 students for a photo using factorial notation? The answer is that's the answer, but using factorial notation. For factorial, right? You have 4 choices for the first, then 3, then 2, then 1, and 4 factorial is 24. We did batting orders. How many ways can we arrange the letters in Hanover? 7 factorial? Now we're going to check that out. Is it right? Oh, good. Okay, doing that from memory. Well, we hit 50-40 yesterday as well. How many ways can we arrange 6 students in the finishing order for a cross-country race if Billy won? Requires a little thought. Got 6 students who can cross the line in cross-country race in different order, but Billy's the winner. So how many ways can we arrange those 6 students? 5 factorial, right? We don't care about Billy now, right? He's gone. I have to arrange the other 5 people, right? So we're dealing with a restriction here. Remember when we did that with fundamental calculus, we had restrictions? So if I did, I could write down the 6 blanks, and I could say, I only have 1 Billy, and they're coming in first place. And then I have 5, 4, 3, 2, 1 students. Or we just think about it as, hey, Billy's done. I just have to arrange the other 5 people. And that happens 120 ways, right? Use 5 factorial. And then the bell should go, right? It's only the bell that just goes.